So in this case, as we have our differentiation, we are going to consider typical questions. You see, if you're answering your questions, there is a part where you are given to differentiate, but they will actually specify that simplification not required. So we want to see how exactly can we answer such typical questions. So this technique that we are going to have is actually a part, guys, that we are going to have on the application. We're going to try by all means applying chain rule. All right, remember your chain rule. So we're going to try to apply the chain rule, but avoiding substitution. All right, so in our simplification, we are actually going to use the condition of our chain rule, but we avoid substitution. So it's going to be that part playing a role, and also to just remember the power rule. Remember the power rule, everything, guys, is going to be part of this, the quotient rule, the product rule, all those rules that we do understand, because it's going to be a combination of what? A combination of these rules together. So, okay, let us just go back to the basics before we consider this. We do understand that in our derivatives, all right, starting with power rule, which is the basic rule that we have in our simplification, which is, all right, so guys, when I say the power rule, it is like something else. This is the one of y is equal to what? X to the exponent of n. If we are given something raised to the exponent of n, we do understand that its derivative with respect to x, to x there, is going to be n, you drop the exponent, then it's going to be x to the exponent of n minus 1. So we are going to see a role where it's going to play when a power is given, where we need to consider this condition. Dropping the exponent, we subtract 1. This is our basic derivative as we do understand, guys. All right. Then number 2, remember your product rule. All right. So I'm just going to give you these ones for the basic of revision. Then, guys, I've said this even with the students that I have for the online classes, that whenever you are revising, make sure that you have the formula sheet with you. Guys, N5 is different from N4. You have the formula sheet with you. If you check, actually, this is our formula sheet. If you check here, if you check the formula sheet, guys, check here, 3 out of 5 pages. 3 out of 5 pages that you're going to have in exam. That those pages, you do not need to learn them in exam. You don't need to learn them. You need to understand them now. All right. So we have got this part of our formula sheet where it is given the product rule. So what I want you to have on your formula sheet is to take this part. Yes, we can have this one. It is fine. But I want us to, we're going to use this one. All right. So what we simply need is that under product rule, we've got these two terms under a product, and this is going to be our derivative. The same part, if we move to the quotient rule, I want you to take the last formula. We're going to use that one in our simplification. So for the quotient rule, the formula, the presentation is supposed to be like this. Then the derivative that we're going to have is going to be that one. I'm going to explain it. But guys, we have this one from our N4 also for the basics of your revisions. All right, so this is what you're going to have. And also the chain rule that we are talking about is also given. Remember your chain rule, 2 functions that you consider. It's a composite functions that you have to consider in that nature. So this is the case, all right? As we saw, on the product rule, we're going to have y is equal to the product of two functions, u and what? And v. So these are functions of x in terms of x, u in terms of x, v also in terms of x. We can determine the derivative there with respect to x by using the formula. It's a formula that you just need to consider. So it's going to be u derivative of v plus you take your v as it is, the derivative of u. All right, so guys, like I said here, there's nothing that is new. We had this formula in our N4. It is just that we are going to need this formula. We are going to need it in our simplification. So know that it is another part that you're going to consider. And also, we have got the quotient. All right, so we also have the quotient rule. Let me quickly write these ones, guys. We know these, guys. So it's going to be ux over vx. That's when you are having a division. So we do understand that it's going to be divide x is equal to, we start with the denominator v. So it's v, the derivative of u, minus, you take u, the derivative of v over what? Over v squared. So we are supposed to know how to use these formulas because already we are given. So to know them, it is fine, guys, to know them, but we just need to consider applications that we are going to have on these formulas. All right, let me just list another part, which is of the, all right, of the chain rule, the function of a function. So the chain rule, given two functions combined together, so you're going to have f of u of x. There are two functions that has to be considered there. So the derivative, whenever you've got functions that can be given as two, like you can express another function in terms of another function, it follows that the derivative of y with respect to x, we can use the formula dy du times du dx. This is supposed to be the same du. So it's du dx, but guys, there's no need for even you to memorize how that formula is given. Like I said, you have these formulas. So it's a waste of time for me to explain that. Let me go quickly to our concept. So we are going to need this. Remember this, all right? We are going to need this part. So these are the basics of applications. Yes, we've got the chain rule, avoiding substitution, then this part. So you are to differentiate something, but you are not supposed to simplify. All right, let's talk about a condition of applying chain rule with avoiding substitution. Let's talk about this in detail. I'm going to give you an example to note. All right, I'm just going to put an example here. If we are given something like this, in our simplification, there are two things. With respect to x when you're differentiating, and with respect to a certain term, we are given y is equal to sine 2x. Okay, you know the answer already, guys, from your basics that, okay, the derivative there of y with respect to x is what? All right, we said the constant, gonna take it here. So it's gonna be 2, sine changes to what? To a cos, and then it'll be like this. You know this answer, but I want us to have it again in a basic way. I want us to start again. Guys, you were just writing before. You did not even understand that. You were just writing. The derivative of y with respect to x, all right, sine changes to a cos. Then when there's a constant, you take that constant there. Even those who are using the formula sheet, they have that derivative, sine changing to what? To a cos, where you just need, okay, if there's a number, you put that number there. You heard that, all right? Even if you go further on those there's a list there. Is it in your N5 or it's N6? Now I'm combining N5 and N6. There's supposed to be a list of formulas that we can use instead of using those standard like that. All right, so that one is supposed to be for N6, no problem. But in this part, you can see that sine is changing to what? A cos. And from your standard derivatives, you know that it will be what? If it is sine of ax, the derivative with respect to x, if it is sine ax, it's going to be a cos of ax. You know this. Okay. But you did not check this into stages. You used what you understood from the standard function. All right. Now, I want us to take this in two ways. We want to branch this. We want to apply the chain rule. Remember the chain rule. We are supposed to have a function of a function. So in actual sense, we were supposed to take this 2x and have it as a function to say, let u be equal to 2x. So that this will be given as y is equal to the sine of u. Guys, don't write anything. I just want you to see. We're not going to use this. Then you write y is equal to what? Sine of u. Then you differentiate this one. Here you differentiate du dx. Then you substitute. But we said we want to avoid substitution. We want to avoid that. All right. So meaning we are not going to use this part. That's why I said do not write anything there. All right. We want to avoid substitution. So to avoid the substitution, we take 2x, the same 2x that we're supposed to use as our u. So we take it as a term on its own or as a function on its own. So you're going to ask yourself here to say, one, what is the derivative of y with respect to the function? So here it is with respect to the function. With respect to the function that you are taking to say the one that you're supposed to use as your u. Guys, knowing this is going to help you to simplify without what? Without where simplification is not required. It's just going to take us some time to understand. But after this, we'll be running like nobody's business. You see. All right, no problem. Let me do this. So I'm saying you're supposed to have the derivative with respect to the function. When I'm saying with respect to the function, this is the 2x, this one. Guys, there's a difference of the derivative with respect to x. With respect to x, dy dx, this one, the derivative of whatever that we are given, the sine of 2x, this one, with respect to x. This is the answer, this one that we have here. This is the exact answer that we are having. It was differentiated with respect to x. We had to also consider the 2 on the derivative. But here I'm saying with respect to the function, it is like this. I'm saying the derivative with respect to this function, which is with respect to 2x. With respect to 2x like this, it means we have neglected 2x on our derivative. So we are going to differentiate sine, neglecting the 2x as if it's not there. You differentiate a sine. That's where this concept plays a role to say sine changes to what? A cos. But you don't use that ax. It's not, because this one is with respect to x. It's with respect to x. Here we are saying with respect to the whole of this. So you ignore it. So you just say, okay, sine changes to what? To a cos. So it was going to be cos 2x like this. We differentiated the sine of 2x, this one. All right. So I'm supposed to write d sine here because I'm not writing like dy dx. So this is d sine of what? Of 2x, which is being differentiated with respect to 2x. So it is going to give us what? Cos 2x. Take note, this 2 here was ignored, the 2x there. That is why we had to use the whole of it. The 2x, this one, is a function. Remember, it is a function of x on its own. So we are going to determine now the derivative with respect to x from where? From that function. That is where we can have the derivative of this one, of this 2x, that 2x with respect to x. Here it was the derivative of what? Of sine, the whole of sine there. The whole of sine 2x with respect to the function that you're given. Here is that function, the derivative of the function now with respect to x, which is going to give us what? A 2. You are differentiating 2x, guys, with respect to x. You're going to get what? A 2. So the answer was going to be the product of these two when we were focusing with a sine on its own, when we were focusing with a 2x with respect to x. The answer will be the product. So to find our answer in this case, we multiply the product of 1 and 2, these two. So we're going to multiply that. That is going to be our derivative of y with respect to x. We multiply these two. So it's 2 times this, which is 2 cos of what? Of 2x. So you were just writing, guys. You were just writing answers previously. You were just writing answers. So knowing this, guys, we can differentiate something by just looking into it. How do we differentiate? We consider a sign to say a sign changes to a cos without focusing on that function of x. Then we multiply by the function, the derivative of the function. We multiply it by that. By doing this, we can actually factorize anything. We can actually differentiate. Look, guys, where am I? Now I'm into factorization. I don't even know. Where is it coming from? All right. I want us to see something we did not understand. We understand this way. I want us to use this one. You know, mathematics, more examples makes more light. So let's say we are given something like this. Y is equal to the sine of x squared minus 1. All right. We want to differentiate this straightforward by just looking into this. So this is what I'm trying to say. The derivative of y with respect to x is going to be what? We are not given any power in terms of this sign. So we go straight. We differentiate sine, this one, the sine of this whole part, with respect to this function. With respect to this function, it means that function is not considered at that moment. It is just going to remain as it is. So the derivative of this sine, this one, is what? Sine changes to a cos. So it's going to be cos x squared minus 1 times the derivative of the function now with respect to x. The function, this one, x squared minus 1. We are supposed to differentiate this one, what is remaining with respect to x. Are we seeing this part, guys? We differentiated by looking into a sign to say a sign changes to a cos. Then we multiply to the derivative of the function. We are done. By this, we have applied our chain rule without substitution. So this is it. This one is just going to remain as it is, cos squared x squared minus 1 times the derivative with respect to x of this. We are differentiating each part with respect to x. So remember from our power rule, this drop the exponent, we subtract 1. So you're going to drop the exponent, then we subtract 1. So that is going to give us what? 2x. Remember, it was supposed to be 2 minus 1, of which 2 minus 1 is going to give us what? A 1. So that is just going to be 2x. This is the condition of our question. So we are supposed to be very careful, guys. Very, very careful in our simplification. So when they say simplification is not required, we just leave it like that. We're done. We're done. But this is what? 2x times cos of x squared minus 1. We have differentiated this. So we have to separate a function, the derivative, the sign, we differentiate it with respect to what? X squared minus 1. We differentiate that function that we considered with respect to, but now with respect to x. All right, let's have another example. We are going to combine those rules. I think in our next class, we're going to have another part we're just going to see with our time so that we have other questions where those product rule, quotient rule can also be used in consideration of this part of our simplification, where the simplification is not required. So you have to be very, very careful in your simplification as you are simplifying or as you are evaluating your questions. All right. Let us say we are given something like this. We want to consider where the exponent is. This time there's an exponent. Y is equal to sine to the exponent of 2. Not 2, let's use a bigger one. Exponent of 5 like this. Then we are given 2x. So when you are given a term, or it can be of a sign, it can be like a trig, it can be exponential, it can be algebraic, raised to a certain power, you start with the power in your simplification. All right? So it always, in your simplification, power first. So we are going to differentiate looking into the power. What am I trying to say? This here that we are seeing is the same as y is equal to the sine of 2x to the exponent of 5. The whole part is raised to the exponent of 5, like this. So in your derivatives, you're going to have it like this. The derivative of y with respect to x, like I said, we have a power there. So we are going to consider the whole of this part here as our f of x, as our function. Remember, this is what you're going to choose to be your u. So you ignore it. You differentiate looking into the power first. As if this one is not there, as if it's not there. You look into the power first. So you drop the power. So it was going to be, remember your power rule, you drop the power, then you subtract 1. Okay, so we're going to drop this power, then we subtract 1 on our power. So this one, as it is, guys, it means as it is. We are not differentiating the sign. We are focusing on the power. So it remains as it is. The sine of 2x raised to the exponent of what? We subtract 1 on our exponent. So it's now to the exponent of what? Of 4. But remember, in our previous case, the part that we're differentiating, it was not with respect to x, but it's with respect to the whole function. They were considering the power. So what does it mean? We are supposed to multiply to the derivative of that function that you were ignoring. Remember, we're ignoring this part. So we are supposed to differentiate that part with respect to x, which is we are supposed to differentiate what? The sine of 2x with respect to x. So this is what's going to be our case. So as you consider, guys, the sine of 2x, you're going to use that part again, where you differentiate sine with respect to 2x, then you multiply to the derivative of this 2x. But as we can see, guys, this one, we can just write our answer. We know what's going to happen there. So this is it. And also here, when the whole of a sine is being raised to a certain exponent, whether it's a cos, whether it's a tan, It simply means the exponent is on that sign here, like here. It was sine to the exponent of 5. It is this one that we wrote like this. So when we see it like this, we are supposed to rewrite back that exponent here, affecting a sign. That is what I'm trying to say there. So it means we're going to have this as what? We're going to have this as 5 sine to the exponent of 4. This is what you're going to have times the derivative with respect to x of this. So you know the sign is going to change to a cos, and we multiply by that 2. So it's going to be 2 cos of what? Cos of 2x. But we're supposed to have it again stage by stage. By this one, guys, we can see it direct. There's no need for us to do that. So this is how you're supposed to have our answer. Simplification not required. So we differentiate a certain part, but that part that you're considering as a function which was on its own, it has to be differentiated again. That part that you consider, okay, there was another one which was on its own. It must be differentiated again. So where the power is, we start with what? The power. We work with the power. We differentiate looking into the power. Then the function that is inside that bracket has to be differentiated on its own. All right, let's consider another one that has got a power so that we can have this. So we are going to have more examples considering now we're going to do question papers. So make sure, guys, you do join the membership so that you do not miss any of the other classes that we're going to have in our simplifications, in our preparations, guys, for the exams which are ahead of time. We are actually working, guys, as much as we can, preparing for these exams that are ahead of time. For those that have been there previously, they know that towards exams like this, most of the times I won't be even available. But now, guys, I don't even know what's happening. I don't even have a holiday. But we're gonna try, guys. We need to cover this as much as we can. So let's also join the membership to support us so that at least we have more of our N5 mathematics. Okay, guys, no problem. Let's finish. This is it. We have a power there. There is a power here. The outer one. I'm not talking about inside the bracket. I'm talking about the outer. The whole of this is going to be considered as a function raised to the exponent of 5. So what does it mean? It means we said when it is like this, power first. You consider the power. So this whole part is affected by the power of what? Of 5. So this is how we're going to have our derivative. The derivative of y with respect to x is what? The power. Remember, you drop the power, then you subtract 1 on the power. So we're going to drop our 5. This is x squared plus cos squared of x as it is, just like that sign that we had, which we had as it is. But we have to subtract 1 on our exponent. So that's 5 minus 1, which is what? Which is 4. We differentiated looking into the power, the exponent. Now we are supposed to look into the function that we were ignoring, this one, that is the one that is being affected by that power. We're supposed to look into it and have it differentiated with respect to x. We are going to differentiate what was under the bracket, which is the whole of this. We have to differentiate it. So in differentiating this, we can see that we have a function on its own, another one on its own. Remember, when you're adding, you just have to differentiate these separately. So this is what you're going to have. dy dx is equal to what? This one, we've already differentiated. We're just rewriting. So that's x squared plus cos squared x to the exponent of 4 times, we are differentiating this. So on differentiating, the first part was going to be direct, guys. As we can see, we differentiate with respect to this one, with respect to x, this x squared. So we're just going to drop the exponent. We subtract 1. So it was going to be 2x. So this one was going to be direct. All right. Times cos squared, the cos squared. Guys, as you are differentiating cos squared, you're supposed to use what? Function of a function, where we have to consider the power there. There is a power. This cos squared that we are seeing here, this cos squared that we are seeing, this cos squared, it is same as cos of x squared, like this. So we are back to a certain function raised to a certain power. Isn't it the same, guys? That's the same thing here that we had. So as we are differentiating this, we are going to use that concept to say this is going to be, we differentiate. Remember, when it is, when you have a power like that, you drop the power. Like I said, you consider the power first, power 2. So you're going to do that. You drop the power. So it was going to be 2 into what? The cos of x as it is to the exponent of what? 2 minus 1, which is what? Which is 1, guys. 2 minus 1 is just 1, which is cos of x as it is. All right, no problem. Let's leave it. Times what? The derivative of what is in this one. Just like what we've been doing here. We're focusing on the bracket. Then when we wanted to differentiate the bracket, we've observed it is following the same thing. So we have to apply that again. So the power is done. What is next? What is inside the bracket? Just like our previous case. So here it's cos. So you're supposed to have a derivative with respect to x of what? Of a cos x, the one that is here. So we are done. We differentiated looking into the power, then into the cos. So as you can see, this is our cos squared that we are differentiating. So here, guys, let us just simplify. Not like we are simplifying, but we are just rewriting like so that we differentiate the last stage here. And some of the other simplification, yes, they say do not simplify, but guys, just try to, some of the other simplifications, you can just simplify them. Anyways, do not worry for that if you do not understand. So this is it here. We say this is 5 into x squared plus cos squared of x to the exponent of 4 times, here we obtained this 2x here. So it's going to be 2x times, this one we can just multiply, guys. Cos x to the exponent of 1 is what? It's cos x. So this one is going to be 2 cos x. All right. Then the derivative of this with respect to x, the derivative of a cos. Remember, cos changes to what? A sign, a negative sign. I mean, this one is going to change to a negative sign. So it will be a negative sign of x like this. So this is the consideration of our question that we were given just like that. So this one, it is a product of all this, all this part. Simplification is not required, so leave it like that. Leave it as it is. So guys, do revise as many questions as you can. We still have a lot of things to be covered. So we need to also to, actually, I just need to thank you guys for everything because your requests are the ones that are important to bring out these topics or these areas, because some of these areas has been done a long time ago and you'll be like, okay, I'm already done with the derivative. Then you'll figure out, oh, there's this part. So if you figure out a certain part, whether you are on membership, you are not on membership, the request for topics is for us all. Us all. Yes, we have to consider sometimes to say, okay, they are members, this and the bad. Topics, guys. Requests, not request, not to say I'm a member or not. Request as an individual. I have this part that is missing. You introduced this part, but you did not finish it. You're supposed to do that so that I go through that. But sometimes, guys, we're doing a lot of things. So you end up like, okay, I have done that topic, I'm done. But you guys, you're not even saying anything. So let's use our comment section to communicate. Let's communicate. Where there's a need to be covered, if you tell me like there's this part that need, I'll actually tell you. I'm gonna work on it that or not. And if I tell you that I'm gonna work on it, then you see, okay, no, 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 this topic, it has taken time. He hasn't worked on that part. Guys, you know my contact. Come to me, ask, how far? How far about that part? How far about that part? I also need to be reminded. Not to say I like to be reminded, guys. No, it's the messages that you put or the comments that you put. How many are they that I receive? Like I have to go through how many a day? So there will be a lot. So sometimes I'll end up like, oh, that topic I did, but I left this part. So this is the importance of you communicating back. So this is it, guys. Let's do revise the topic, it's not like, can we say a topic? The subsection of our differentiation. We are going to notice this. I want you to go through your question paper. For those who are revising without using question papers, guys, you are making a wrong mistake. That's a mistake. Use question papers in your revisions. So you are going to notice that mostly your question 2.2, all right, is going to be that part where simplification is not required. So this part can carry a lot of marks, 7, 9 marks, depending with the question that you're given. So there will be 2 questions mostly that you'll be given there, where the simplification is not required. So in our next class, we're going to look into the question papers. So again, if you have a question paper that you have been doing and the simplification, where the simplification is not required, is giving you a challenge, let's know about that. That's the purpose of what? The comment section. Let's communicate so that we can work on that question also. So this is it, guys. Till we meet again.